Hey, that's short. Okay. All right, mic check, mic check, mic check, mic check. All right. Hello again. So this video is going to talk about a few things. Number one, our goal is to talk about solving systems of equations by graphing. Okay. This is one of the ways that you can solve a system is through graphing. Okay. To get there though, sometimes you'll have a set of equations and they're not in slope intercept form. And so, you don't necessarily need it to be in slope intercept form if you remember how to graph, right? Because you can solve for the x and y intercept and stuff like that. But if it's easier for you to put it in slope intercept form so you can see the slope and the y intercept, you have to know how to manipulate your equation to get it in that format. Okay, so it won't always be so cut and dry for you. So when we look at the example here, and what I'm gonna do, y'all, is I'm gonna upload this. Into Schoology so you can refer to it as notes, right? So when we look here, it's in standard form, right? So 4x minus 2y equals 12. This is not in slope intercept. To be in slope intercept, it needs to be in this final format down here, right? This is what we want. But you have to manipulate the equation in order to get it like this. When you see this equation here, remember our slope is 2. So that means we're going to rise 2 and go over 1. And remember, when we graph, we always go to the right. When the slope is positive, you go up. When it's negative, you go down, but you always go to the right. Okay, and when we look here, your y-intercept is -6. So when I plot this function, I'm going to start at -6. I'm going to go up 2, right 1, up 2, right 1, up 2, right 1. Okay, get at least 3 dots on there. Take a straight edge, connect them, so you're good to go. Okay, but when the equation is first like this, we got to get it to that format. So what you do is you want to get the y by itself, right? So you get rid of the x term. Right now it's positive 4x, so we get rid of it by subtracting 4x to both sides. Boom. That's what they did here. And then we got this over here. Okay. We have the 12 minus 4x, but they rewrote it as -4x plus 12. Same thing. And then we bring down our negative. That's the key. Remember this subtraction from 2, that's -2. We're going to divide by -2, and then we get our final slope intercept format right there. So let's play around with this a little bit before we get to graphing. So keeping this in mind, when we look at number 1, right, we have x plus y is equal to -15. I want to get the y by itself. That's my goal. Slope intercept, I got y on the left, 1 y on the left. Okay. Right here, I don't have 1 y just by itself. So I got to get rid of the x. So how do you do that? Well, you do the inverse operation, right? You do the opposite. Right now, my x is positive, or it's a positive 1x. So to get rid of it, I'm going to have to subtract 1x. Nah. I'm going to subtract 1x. Okay. Positive 1x minus 1x, they cancel. So I bring down Mr. 1y. All right, Mr. 1y, I'm good. Right, I got y isolated, I'm good on the left. Now I gotta structure things so I'm good on the right. Okay, you can't subtract 1x from 15, they're unlike terms, so you bring it all down. So you have negative 15 minus x. But remember, to be in slope and form, I put my x in front of my constant. So I'm just turn things around here. So my final answer is y equals negative 1x minus 15. This is my final answer in slope-intercept form. Again, technically, I could leave it like this, right? But slope-intercept form, I want to put my slope in front. That's the only reason why I kind of turn things around. That's what they did up here, actually, right? They did 12 minus 4x, but they switched it around. Oop. They switched it around. So the slope is in front. So they put negative 4 plus 12. See, same principle here. Negative 15 minus x. Again, I flip it around, negative x minus 15. Up here, 12 minus 4x. If they flip it around, negative 4x plus 12. Right? That's how you get it in slope-intercept form. All right, let's talk about number 2. Number 2, I got 2y plus 8x equals 1. So same situation here. I do not have x by itself. I'm sorry, y by itself. I don't have the y by itself. So I got to get rid of whatever is associated with the y term, right? So I got to get rid of the plus 8x. So how do I do that? I subtract. So I subtract 8x here, subtract 8x here. Boom. Plus 8x minus 8x, they cancel. Bring down Mr. 2y. Okay. So again, same principle here. If these are unlike terms, right? I can't subtract 8x from 1. I can't do that. It's apples and oranges, right? So I got to keep them as apples and oranges. I gotta bring everything down. So then I have 1 minus 8x. But just like we said over here, we want the slope in front, right? So turn your stuff around. So then you have 2y equals, keep my negative, right? Keep it, negative 8x plus 1. My 1 is positive, plus 1. My 8 is negative, minus 8x. All right. Right now I got 2y. I don't want 2y, I want 1y. So I have to divide by 2. Okay. Gotta divide by 2. So then my final answer is going to be y equals negative 8 divided by 2. It's negative 4x. 1 divided by 2 is 1/2. Right? So here, my slope is negative 4. That means I'm going to go down 4, right 1. My y-intercept is 1/2. And I start my graph at 0.5. Over here, my slope is negative 1. So that means I go down 1, right 1. My y-intercept is negative 15. That means I start making my function at negative 15. Okay. Let's go down here, number 3. So number 3, same principle, right? Same principle. What I have to do for number 3 is I need to change this into slope-intercept form. So I need to get y by itself. So I got to get rid of the minus 2x or the negative 2x. So how do I get rid of that? I do the opposite. So I add 2x to both sides. Minus 2x plus 2x cancel. Bring down Mr. Y. These are unlike terms, so I bring them down as well. 1 plus 2x. But like we were saying before, we got to do the switcheroo because I got to have my slope in front. So when I rewrite everything, it's going to be y equals, bring my slope in front, so positive 2x, so 2x, and bring my y-intercept. Okay. Good stuff here. Good stuff, good stuff, good stuff. Okay. So this is the general principle that you have to do when you have an equation that's not in slope-intercept form, right? Move the x variable onto the side with the constant, leave the y by itself. We got to isolate the y by itself, okay? Remember, when you're, manipulating stuff, you want to put your slope in front of the y-intercept, okay? And make sure you keep the sign that's attached to your x. Keep it when you're doing your rotating around, okay? All right, cool. Moving on to systems now. So when we talk about systems, that means we're trying to find the point of intersection. Right. So those math problems that deal with, a train leaves here, a train leaves Atlanta, train leaves Columbus, when are they going to meet, right? Something like when they're going to intersect with each other. So we're looking for. And that problem was kind of a different application. So but but we have 3 types of solutions. All right, 3 types of solutions to systems. Okay, you have no solution, one solution, or infinite solutions. All right. If you have So again, this is going off of what we talked about before, right? When you're getting ready to graph your lines, right? And they're both in slope intercept form and you put them on a graph, right? A system, we're talking about 2. Could be more than 2, but for our purposes, we're talking about 2. So we're talking about graphing 2 linear equations. And when you're graphing 2 equations, they can be parallel. Oh, can y'all see that? They can be parallel to each other. Yeah, I'm gonna do the let's do the paint. That shows up a little bit better because it's too much glare. Yeah. Yeah. No. Green doesn't show up any better. But anyway, no solution, right? That means those lines have the same slope. Okay, so when you graph two lines, right? You graph two lines, they have the same slope, they got the same rate of change, they're moving the same, right? But because they have a different y-intercept, they're never going to touch each other, right? If they continue to maintain the same slope, they continue to maintain, they're never going to intersect. Never, ever, ever. So that's why we say there's no solution there, right? Because remember, what we're looking for is where we want them to intersect. We want them to cross paths. When they got the same slope, they're not going to cross paths. That's why we say no solution. Okay. Second version. This is what we want. So we're looking for here. Bam. We're looking for the point of intersection. Okay. The one solution we're looking for is an ordered pair. So you're going to say, you know, they intersect at 1,2. You know what I'm saying? But you have to interpret whatever that solution means, right? So when you think about the problem, what does the 1 represent in terms of the independent variable or the x, right? What is the 4, you know, or the y term? What does that represent in terms of the problem, right? So not only do you have to give the solution, like the location of the point on the coordinate plane, but also talk about what does it mean in terms of the problem. Okay. Last one. Infinite solutions. That means when you graph the first line, you graph the first function, you know, you get your slope and y-intercept. Everything's looking good. Everything's looking good. Everything's looking good. Then when you get ready to graph the second one, oh, what? You're doing the exact same thing. It's infinite solution, right? When the lines are on top of each other. In that instance, they have the same slope, same y-intercept. They're the same. It's the same thing, but they're going to try to package it. They're going to try to package it differently to throw you off, right? But when you put them in slope intercept form, both of them, you're going to see, oh, all right, bet they got the same slope, same y-intercept. And you're also going to see that on the graph as well. Okay, so when the two lines are on top of each other, they share the same points, right? Into infinity. That's why we say infinite solution. Okay, so no solution, they're same slope, right? It's like they're parallel to each other, same slope, different y-intercept. One solution, it's an ordered pair. It's the location that they meet, and then remember to interpret what the ordered pair represents in the problem. And then you have infinite solutions, right? Where both lines are lying on top of each other. It's the same thing, right? So there you go. And I guess what I can do is slide this in Schoology as well, so you have access to this. Okay. So what I'm going to do is I'm going to go over a skills practice, right, which is similar to your homework practice, which was your homework assignment for this. All right. Oh, it's not what we want to do. All right. So because you all are going to do this assignment digitally, you know, you can use like Desmos, you know, to kind of go over this since I'm not there with you. So if you're unsure about your answer, use the Desmos graphing calculator. Punch in the two equations, and then you'll see where they intersect. Okay. So solve each system by graphing. Take a look. Number one, first of all, they have the different slope and a different y-intercept. So I'm gonna look for one solution, right? They got a different slope. Off top, different slope. So I know it's not gonna be no solution because the slope is different. I know it's not gonna be infinite because they don't have the same y-intercept either. So I'm going to have an intersection here. I'm going to have one. Okay. So let's plot this bad boy. First one, our y-intercept is 4. So boom, goes there. Right, y-intercept is 4. My slope is 1. So I go up 1 over 1. Since I'm running out of room, I could maintain the same pattern in the opposite direction. Take Mr. Straight Edge here. You know, label this as y equals x plus 4. You know what I'm saying? Make my little flag. And there we go. Next one, y equals 2x minus 2. My y-intercept is -2, so I start there. 1, 2, put a dot there, boom. My slope is -2, so I go down 2, right 1. Okay. Since I'm running out of space, I'm going to maintain the pattern in the same in the opposite direction. Hey, bingo. All right. Y equals -2x minus 2. All right, cool. So just take note of what I did, right? Especially if you're going to do this by hand, if you have, you know, colored pencils, highlighters, different pens, whatever the case may be, label it. If you don't, put a little flag on it so you understand which equation is which and you don't lose sight of what it is. Okay. So our solution is the point of intersection, which is right here. So our solution is 1, 2. Hold on, 1, 2, 1, 2. Solution -2, 2. That is my point of intersection. Okay. Also, you can check it to see if it's true. If I put in -2 for x, 4 plus -2 gives me a y value of 2. Boom. But don't just check one, check both. Let me plug it in the second equation. -2 times -2 is 4. 4 minus 2 equals 2. I'm Gucci. Gucci Mane LaFleur. So I'm good now. That's how you know you did it right. Okay, that's how you know you did it right. And like I said, you can go to Desmos graphing calculator, punch in these two equations, and see if you get the same solution of -2, 2. Okay, let's move on. Number 2. Hold on now. Same slope. So that means no solution or infinite. If it's infinite, it's got to have the same y-intercept as well. Do they have the same y-intercept? No. So you can already say no solution. You can already say that, homie, because you know they're going to be parallel to each other, right? But let's do it anyway to drive the point home. Okay. First one, my y-intercept is -1. So -1. Slope is 5. So I go up 5, right 1. 1, 2, 3, 4, 5. 1, 2, 3, 4. I ran out of room there. Okay, camera's in the way here. Let's see if we can. There you go. Y equals 5x minus 1. Okay. Take a look at the other one. 5x plus 10. Oh, I guess I should have been smart about my scale, huh? Okay. Yeah. 1, 2, 3, 4, 5. Yeah, I should have been smarter about my scale. But you know, it is what it is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You know, just humor me for a second, right? I'm saying it should be something like this. You know, should be something like that. See, that's why you gotta look at stuff. You gotta pay closer attention. So that's my fault. But the point remains, you would see something like this, right? Because they have the same slope, they're traveling, they have the same constant rate of change, but because the y-intercepts are different, they're never going to intersect because they're going to maintain the same distance apart. Okay. But again, you know it's no solution before you even graph because they got the same slope and a different y-intercept. Okay. Número 3. Excuse me. Okay, number 3. Okay. First of all, look at number 3. Both of them are not. They are not in slope intercept form. So I got to change them so that they are. Okay. The first one is good. My slope is 1. My y-intercept is -1. So I ain't got to worry about that one. It's this one here that I got to fix. Okay. So how do I do that? Well, I got to get rid of my -1x or minus x. So how do I do that? I got to add x to both sides. Okay, when I add x to both sides, I'm going to have y equals -1 plus x. And then remember, I'm going to do my switcheroo so it's properly in slope intercept form. Then when I do my switcheroo, my final answer is y is equal to positive x. So x, it's a -1 minus 1. Uh-oh. Guess what day it is? See, we got the same equation here. That's why it's important for you to understand how to move and manipulate from, whatever they got going on into slope intercept. So you can clearly see the slopes are the same, the y-intercepts are the same. And when that's the case, when it's the same slope and the same y-intercept, it's infinite solution. So you say infinite solutions. Yeah, this video is dragging on, but it is what it is. Y'all can skip forward and get to the part you deem important. So let's graph them. First one is -1 is my y-intercept. So go down 1. My slope is 1. So that means I go up 1, right 1, up 1, right 1. Okay, remember when you don't see the coefficient in front of the x, it's assumed to be 1. Okay, and you're good to go. All right. Again, these are very similar to the problems you'll have on your homework assignment. Now let's get to a word problem. When you have the word problem, you got to read carefully. And once you read carefully, you want to come up with 2 equations that you can graph based on the word problem. So you got to read what's going on in the word problem, read what's going on, and then try to come up with 2 equations. Write them, go ahead and write them in slope intercept form. Right, write them in slope intercept form so that you can graph them immediately. So let's go. There are 33 students in the chess club. There are 5 more boys than girls in the club. Write and solve a system to find the number of boys and girls in the chess club. Okay. So one piece of information is incredibly obvious. I think most of us can easily pinpoint that. There are 5 more boys than girls. There are 5 more boys plus girls. 5 more boys than girls. 5 more boys than girls. 5 more boys and girls. So the boys, B, right? 5 more boys than girls. The boys are equal to the girls plus 5, right? Girls plus 5 is equal to the boys, is what this is saying. There are 5 more boys than girls. So the girls plus 5 is equal to the boys. Okay, so this is one of them, right? This is one of them. Hey, and if you don't like using B and G, replace them with X and Y if if that makes you more comfortable. So now, what else can I use? There are 33 students. 33 students. So I know I can use that information. Something is equal to 33. I just don't know what it is. People in the club, right? But use the 2 variables you've already designated in the previous one. So the boys plus the girls. Boys plus the girls is equal to 33. Boys plus girls is equal to 33. Okay. boys plus girls equals 33. All right, now we're doing something. Both of these are not in slope intercept form. The first one is, right, because I've solved for one of the, I solved for B. And you can, replace B with Y. So Y equals X plus 5, right? And then Y plus X equals 33, if that's what you want to do. I need to change this bottom one into slope intercept form. So how can I do that? Subtract G. And my G's look like 6s. I apologize. So now we have B is equal to 33 minus G. And then remember, do the old alley-oop. B is equal to negative G plus 33. These are my two equations. Okay. Again, how do we do that? 5 more boys than girls in the club. That's how I got B equals G plus 5. 33 students in the club. Pink and green, AKA say y'all. My boys plus my girls is equal to 33. That's how I did that. This equation, I needed in slope intercept. That's why I subtracted G, flipped it around. Now I'm good. So I'm going to use these two. And again, replace the B with Y if you want. So we got Y is equal to X plus 5. And then equation B, we have Y is equal to negative X plus 33. Equation B. Now, how in the heck am I going to do something like this when I have 33 as a y-intercept? Okay, so be smart and go, use a scale that makes sense. So 1, 2, 3, 4, 5. I guess I could count by 6s. 6, 12, 18, 24, 30. Still not high enough. Could go by 7s. 7, 14, 21, 28, 35. It's going to be a little bit off, right? So that's why I said check your work with Desmos. Okay, so here we go. We're going to make an approximation. I'm going to make an approximation. And they want us to solve by graphing, so that's the method we're going to stick to, right? If you already know how to do systems, there's a bunch of ways we can make this work. But we want to do graphing, so let's graph, guys. All right, here we go. First one, X plus 5, if I'm counting by 7s. And maybe I need a reminder, right? So 7, 14, 21, 28, 35. So starting at 5, it should be somewhere around here. Oh, this is going to be ugly. So we could, to make it easier, we can do ordered pairs. We can make a table, right? So X is 0, is 5. X is 1. 1 plus 5, 6. X is 2. 7. X is 3. 8. You know, 4, 9, right? 5, 10. All right. If you want some ordered pairs, right? If you want some ordered pairs to kind of help you plot here. So I got 0, 5, which is kind of ugly here. Boom. 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5. Okay. 1, 6, a little bit higher. 2, 7, bam. 3, 8, a little bit higher. 4, 9, a little bit higher. 5, 10, a little bit higher. My stuff is looking ugly. But we've gonna make this thing work though. Standing on the top. Y equals x plus 5. Okay. Let's do another one. Here we go. We have another x and y table here. All right. So y equals negative x plus 33. Yes, indeed. Yes, indeed. Yes, indeed. All right. We have 0, 33, 1, 32, 2, 31, 3, 30, 4, 29, 5, 28. It's lovely. Just this is lovely when math gets messy. Okay. But the point is, with my few points, I should be able to draw my line and then I should be able to make a prediction. So 0, 33 is somewhere around here. 132 here. Uh-oh. Shoot, it might even come into my table out here. 231. Yep. Yeah, this is getting pretty ugly, curvy. 330. 330. Yep. 429. Yep. 528. Bam. So you see, we gotta keep going. We just gotta keep going. So let me see where I can do this. Standing on the top. Ugly there. We have an answer. Question is, where do you think that is? That's the $1 million question. Uh-oh, here we go. See where we're at. Keep that ruler straight, Carby. It's a little bit below 21. Oh, no, a little bit higher than that. I know. Here. Caught at about 19. All right, let's see. Looks like a good 19. 19. Yeah. 19. Yeah. 19 on the Y. Okay. And so since I can't really draw my table out, if I have one of the numbers, then I could approximate, right? So if Y is 19, right? Because it's up like 19. X plus what number? I'm sorry, 5 plus what number gives you 19? Well, that's 14. So 14 plus 5, 19. Okay. Okay. Now, to test it and see if it works, right? Test it and see if it works. We're going to put it in the other equation as well. So if 19 is my Y, 19 equals negative X, and negative 14 plus 33. And guess what? Negative 14 plus 33 is 19. It checks out. My solution is 1419. Yes. Okay. So obviously I didn't use the best scale. Okay. Scale does, in theory, it does make sense, but it gets a little sloppy. I could have used bigger numbers, maybe counting by, I don't know, 10, So like 10, 20, 30, 40. That might have made a little more sense instead of 7. But I was able to get my solution, so I'm satisfied with that. Okay. Now the last part, what does the solution represent? Okay. That's why we had to define what our variables were. B is a boy and G a girl, right? And we said B is Y and G is X. So this really means that there are 14 girls because my X is G. My X is G. 14 girls. And 19 boys because B is equal to Y in the chess club. Oh, zooming out. So that's what it means by interpret. Once you get the solution, think about the problem, right? Think about the problem and tell me what the ordered pair means in terms of the problem. The problem is about the chess club and trying to figure out the number of boys and girls in there. So my boys, 19, girls, 14. Okay. So this should be more than enough review for your homework. Holla at me if you have any questions.